I'm going to take you through some key concepts based on which questions are asked in these exams, right? Okay. So let's start with functions. Now, in functions, these are the four typical functions based on which a lot of questions are asked, right? Now, in general, we have four type of functions, which are we have four type of functions, which are polynomial, exponential, logarithmic, and trigonometric. So these are the four type of functions, and out of these, there are different forms of these four types of functions. And out of these are the four types based on which questions are asked. So the first type is the modulus function. Now, as you know that any modulus function will have a point of inflection, right? So if I have y is equal to f of x, that means wherever f of x is equal to 0, there will be a point of inflection. So the graph will look like this, and this point would be where f of x is equal to 0. So therefore, any function of this form or of forms which are equivalent will have a point of non-differentiability where fx is equal to 0. So this is in the simplest form. So if you consider the function mod x, then mod x would be non-differentiable when x is equal to 0. So similarly, if you consider fx will be non-differentiable when fx is equal to 0, but the function will be continuous. Now, there are several adaptations of this function, right? The simplest adaptation is y equal to mod of f of x plus mod of g of x, can be plus or minus h of x. This can be one simple adaptation. And in this, again, the same rule applies, that the function y will be non-differentiable for fx equal to 0 and equal to 0. So this is the simplest form of adaptation of this kind of a function, right? Okay, now let's look at an example. Uh, okay. Look at this example. This is exactly what I just explained. So the function fx is defined as mod of x plus 1 plus e to the power x. And the question is, where is it differentiable? So it is differentiable at all points except at x equal to 0 and x plus 1 equal to 0, which is x equal to -1. Okay. The second type of adaptation of this function is of the form g of mod of f of x. So for example, ln of mod of root of x square plus 1, or not x square plus 1, let's say x square minus 1. So that means this function will have a point of discontinuity when f of x, which is this one, is equal to 0. That means x would be equal to plus or minus 1, right? So that means this function will not be differentiable at x equal to plus or minus 1, right? And also notice, since this is a radical function, that means fx is radical, that means x square plus 1 has to be greater than equal to 0. X square minus 1, sorry, has to be greater than equal to 0, or x square has to be greater than equal to 1. Therefore, x has to be greater than equal to 1, because if I take x less than equal to 1, then what happens? Then this value x square plus 1 will remain greater than equal to 1. So it has to be either greater than equal to 1 or less than equal to minus 1, right? So x will not exist in the range of minus 1 to 1. So that means the function will be discontinuous at x equal to plus or minus 1. So this is another type of adaptation of the concept of a mod function. Okay. The second kind of function is the box function. Now, wherever you see a box function, this means the integer which is less than or equal to fx, greatest integer which is less than or equal to fx. So when fx is negative, then it will be the negative integer before fx, and when fx is positive, it will be the positive integer before fx. And when fx lies between 1 and 0, then box of fx will be equal to 0. When fx lies between 0 and negative 1, box of fx will be negative 1. Now, this function f of x, box of f of x, it will be a step function which will be discontinuous for all integer values of x. So the plot of x versus box of f of x will be step functions like these. So it will be step functions like this. Where it is discontinuous at each of the integer values. So this is x equal to -2, this is x equal to -1, this is x equal to 0, 1, 2, 3. So for all these values, the function f of x, box of f of x will be discontinuous. So which means this function will not be continuous and therefore will not be differentiable for any integer value of fx. Right? Now, there can be several questions based on this. One of the questions is uh, if box of log 1 plus box of log 2 plus box of log 3, etc., up to box of log n is equal to n. Find the value of n. So this is one simple application of this. So here you can see that it is talking about box function, sum of box functions. So log 1, log 2, log 3 up to log 10 is less than or equal to 1. Log 10 is equal to 1. So log 1 is 0. So log 1 up to log 10 is less than equal to 1 and greater than 0. So therefore, greater than equal to 0. So therefore, all the logs which are from 1 to 10 will be will have positive fraction values, right? So therefore, the box function of all of these, box of log 1, 2 box of log 10 will be equal to 0 because this is the largest integer less than equal to all these values. Similarly, box of log of 11 to box of log of 99 will be, sorry, this would be equal to log 9. Box of log 10 to log 99 will be equal to 1 because box of log 10 is 1, log 10 is 1, so box of log 10 is 1, and box of log 100 is 2, so box of log 100 is 2. So therefore, all numbers from 10 to 99 will give you a value of 1 when you take the box of their log. So that means if I add up all the numbers from log 1 to log 99, I will get sum of box of log of x from 1 to 99. This will be 1 into 99 minus 10 plus 1, which is 90. So this sum will be 90. So if I take n equal to 99, then I'm getting the left-hand side as 90 and the right-hand side is 99. So that means I have to add up few more numbers to match up the left-hand side with the right-hand side, right? So the next number would be 100 and the left-hand side will increase by plus 2. The right-hand side will increase by plus 1. So that means by how much should the left hand side increase to match the right hand side. So let's say this needs to increase by amount of y. So for each y, the left hand side will increase by 2y. So that means 90 plus 2y will match up to 99 plus y. So that means y would be 99 minus 90, which is 9. That means I need 9 more values on the right hand side and left hand side to make them equal. So that means 99 plus 9 would be 108. So the value of n would be 108. So these are simple examples of uh, box function. Another example of box function, which is given quite frequently, is how many points of discontinuity will the function mod of x, let's say x square minus 2, have in the interval of, let's say, minus 2 to plus 2. It's an open interval. So that means x is lying between minus 2 to plus 2, means x square will lie between x square will lie between 0 and 4. If x lies between minus 2 to plus 2, x square has to lie between 0 and 4. So therefore, x square minus 2 has to lie between 4 minus 2, which is 2, and greater than equal to minus 2. So x square minus 2 has to lie between minus 2 and plus 2, right? So that means x square minus 2 will get integer values at x. This will have integer values of minus 2, minus 1, 0, and plus 1, right? So that means what would be the values of what would be the points of discontinuity? The points of discontinuity will be x square minus 2 equal to minus 2, which means x is equal to 0. Then x square minus 2 equals negative 1, which means x square equals 1. That means x equal to plus or minus 1. Then x square minus 2 equals 0. So that means x square equal 2. That means x equals plus minus root 2. And x square minus 2 equals 1. That means x square equals plus 3. That means x equals plus minus root 3. So that means 2 plus 2 plus 2 plus 1, right? So there will be 7 points of discontinuity. So these are the kind of questions that are given based on this particular concept. The third function, which is very, very important, is of the form fx plus 1 by fx, and there are several problems that can be given based on this concept. This is the most important concept in functions. Now, if you look at this function in the simplest form, this is x plus 1 by x. And if you plot this function, x versus y, the plot of this function will be an asymptote like this and another asymptote like this, where the values of the maxima and the minima will be plus and minus 2. So this is the minima would be 2 and the maxima would be minus 2. So this is the nature of the base function x plus 1 by x. Now, the variance of this will depend on the nature of fx. For example, if I take x square plus 1 by x square. Now, x square can never be negative for any real values of x. So therefore, the graph of x square plus 1 by x square will lie only in the first quadrant. So this graph, this function is similar to this function, but the values will be always positive, right? Okay. Now, if I have x cube plus 1 by x cube, here again the function can exist in both the first and the third quadrants. So if it is a polynomial function, y equal to x to the power n plus 1 by x to the power n, then the graph will exist in the first quadrant if n is even. And the value will, of course, remain the same. The minima will be 2. And that will happen when x to the power n equals 1 or x equal to 1. So if n is even, that means if the power is even, then y will lie only in the first quadrant. If n is odd, then it will lie in first and third quadrant. And there will be a maxima and a minima, where the minima will be 2 when x to the power n equal to 1 or x equal to 1, and the maxima will be negative 2 when x equal to negative 1. So this is the behavior of this function if it is a pure polynomial. Okay. If this function is exponential, then y equals e to the power x plus 1 by e to the power x, which means the graph of this function will be always positive, and it will exist in the first and the second quadrant, because the graph of e to the power x is like this, and the graph of 1 by e to the power x is like this, and this is the point x equal to 0, y equal to 1. So the graph of e to the power x plus 1 by e to the power x will be this one, where this point will be 2. Okay. So this is true if the graph, if the function is exponential. Now, if the same function is logarithmic, y equals log y, log x plus 1 by log x. Now, log x plus 1 by log x. Now, obviously, the graph of log x is this. And what is the graph of 1 by log x? It will be just the reciprocal of that. So, right? So this would be so. Yeah. So if I plot 1 by log x, then x versus 1 by log x will be when x is minus 1, when x is minus half, then log x is log of minus half, which is non-existent, right? When x is 1 by 2, log x would be minus log 2. So this would be 1 by minus log 2, which would be negative, right? Minus 1 by log 2. When x is equal to 1, this would be 1 by 0, which is undefined. When x is 2, this would be 1 by log 2, which would be greater than 1, right? So that means for all values of x which is greater than 1, the value of 1 by log x will be positive. And for all values of x lying between 0 and 1, the value of 1 by log x will be negative. So that means 1 by log x will be a function like this, right? So that means if I plot log x plus 1 by log x, it'll be existing at which two quadrants? The first quadrant and the fourth quadrant. So in the first quadrant, it would be having a minima when log x is equal to 1. That means x is equal to 10. So there log x will be minima. Log x plus 1 by log x will be minima, right? So that means this function will have its minima, which is going to be 2 when x is equal to 10, right? Right? And in the fourth quadrant, this will be this will be existing only when x is lying between 0 and 1. And the graph here would be equal to like this, right? So at x equal to 1, this goes to infinity, and from x equal to 1, from x equal to 1 to x equal to infinity, the graph will lie in the first quadrant. So therefore, the minima of this would be 2 when x is equal to 10, and the maxima of this would be -2 when x equal to, when log x is equal to -1, that means x is equal to 1 by 10. So this is the application of this when we have a log function. Next, when we have a trigonometric function, sin x plus 1 by sin x. Now we know that the value of sin x lies between +1 and -1. So if I plot x versus y, where y is sin x plus 1 upon sin x, then the value of y will be always lying between 1 plus 1 upon, sorry, sin x plus 1 upon sin x, which would be when sin x is equal to 1, that means x is equal to pi by 2, then this will reach its minima, which is going to be 2. Once again, when x is equal to x is equal to 5 pi by 2, then once again it will reach its minima. So that means when it is lying between 0 to pi by 2, then sin x will lie between, x is lying between pi by 2 to 0, sin x will lie between 1 and 0. So that means sin x will be a fraction, and therefore a fraction plus a reciprocal of that fraction will be always greater than 2. So that means the graph of sin x plus 1 by sin x will be like this up to x equal to pi by 2. Then once again, when x is lying between 0 to pi, sin x will be positive again. So that means sin x will lie between, I'm sorry, this is pi by 2 to pi. So sin x will lie between greater than 0, less than 1. So that means this will go up. This is pi. So then from pi onwards to 2 pi, the graph will be in the negative quadrant. So this is 3 pi by 2, then this is 2 pi. So from pi to pi by 2, the graph will be in this quadrant. Pi values will be negative. And the maximum value here would be minus 2, which will happen when x is equal to 3 pi by 2. From 2 pi to 3 pi, again, the graph will come in the first quadrant. So this would be the behavior of this graph when it is a, a sine function. Okay. So now if we combine this, and the question is, if I have sine x plus 1 by sine x equals e to the power x plus 1 by e to the power x, then how many uh, points of intersection will this graph have? So that means I have to check for the left-hand side graph and the right-hand side graph. So the left-hand side graph is sine x. So this is like this from 0 to pi. Then from pi to 2 pi, it would be like this. And then again, it will be like this, and so on. And on the right-hand side, I have e to the power x plus 1 by e to the power x, which will be a graph which is going to be like this. So that means it will have one point of intersection here, which will lie in the first quadrant. So here for x equal to pi by 2, the left-hand side is minima, and for x equal to 0, the right-hand side is minima. And if I go to the negative side, so at x equal to minus pi, between x equal to minus pi and 0, the left-hand side graph will again be like this. So that means this function, this equation will have only one solution. Clear? Similarly, if it is given that sin x plus, or let's say cos, I take cos x now. Cos x plus 1 by cos x equals x plus 1 by x. So how many points of intersection will this have, or how many solutions will this have? So once again, we do the graphs of the left-hand side and the right-hand side. The right-hand side graph will be like this and like this. For x equal to 1, this is plus 2. For x equal to minus 1, this is minus 2. So this is my left-hand side graph. Sorry, this is my right-hand side graph. And my left-hand side graph is cos x plus 1 by cos x. Now, cos x is 1 here, minus 1 here, 0 here, and 0 here. So that means between uh, pi to between 0 to pi, cos x will lie between minus 1 to plus 1. Between 0 to pi by 2, cos x will lie between 0 and 1. So that means the value of cos x will be equal to 1 when x equal to 0. It is equal to 0 when x equal to minus pi by 2 and plus pi by 2. So minus pi by 2 means roughly minus 1.5. Pi is equal to minus 3. So that means at x equal to minus pi by 2 and at x equal to pi by 2, the value of cos will be 0. Therefore, cos x plus 1 by cos x will go to infinity. And it's in the first quadrant, so uh, first and fourth quadrant, so cos is positive. So that means from minus pi by 2 to plus pi by 2, cos will be positive. So cos x plus 1 by cos x will remain in the first and the second quadrant, and the minimum value would be plus 2 when cos x equal to 1, that is when x equal to 0. So the graph will look like this. Right? So this is at x equal to pi by 2 to minus pi by 2. So there will be one point of intersection out here. And when I go to the next value in the negative quadrant, which is from uh, minus pi by 2 to minus 3 pi by 2, minus pi by 2 to minus 3 pi by 2. In this, cos is negative. So that means when this is minus pi, cos will attain the value of cos x plus 1 by cos x will attain the value of minus 2. So that means there will be one point of intersection out here. So there will be two solutions for this equation. Clear? So this is the application of this function x plus 1 by x or fx plus 1 by fx. Okay. The next one. This is a function of the form f of x to the power g of x equals 1. Now this means that g of x equal to 0, where f of x is an element of all real numbers except 0. And the second case is f of x equal to 1 and g of x is any real number. And the third case is f of x equals negative 1 and g of x is an even integer. So these are the three possible cases. Once again, if I take an example, f of x and g of x can be anything, right? So they can be a polynomial, they can be exponential, they can be trigonometric, they can be logarithmic. So if I take polynomial, let's say I take x square minus 5x plus 5 to the power x square minus 3x plus 2 equal to 1. So from the first criteria, I see that x square minus 3x plus 2, which is equal to x minus 2 into x minus 1 equals 0. So x equal to 2 or 1. Now, I have to be careful so that I check that for these values of x, the base should not become equal to 0. So here, if I put x equal to 1, I get the base as 1. If I put x equal to 2, I get 5 plus 4, 9, minus 10, which is minus 1. So it is not 0. So therefore, these two are two values of x. The next case is when the base is equal to 1. That means x square minus 5x plus 5 equal to 1, or x square minus 5x plus 4 equal to 0. So which means x minus 4 into x minus 1 equal to 0, or x equal to 1 and 4. But 1 is already included here. So the third solution is x equal to 4. The last case is fx equal to negative 1, which means x square minus 5x plus 5 equal to negative 1, or x square minus 5x plus 6 equal to 0. That means x minus 2 into x minus 3 equal to 0, which means x is equal to 2 or 3. Now, I have to be careful that for the values that I'm seeing here, the power should be even. So the power here is x square minus 3x plus 2. So if I put x equal to 2, so x square will be even, 3x will be even, plus 2 is even. So for x equal to 2, the power would be even. And x equal to 2 is already a solution here. X equal to 3, for x equal to 3, x square would be odd, minus 3x would be odd. So odd is even, plus 2 is even. So that makes it even. So that means x equal to 3 is another solution. So 1, 2, 3, 4 are the 4 solutions of x in this case. Okay. Now let us take an example of this where we take trigonometric and trigonometry. So tan x to the power sin x equals 1. That means case 1 is sin x equal to 0 and tan x is not equal to 0, which is not possible. Wherever sin x is 0, tan x is 0. So this solution will not hold. Second, tan x equal to 1. So if tan x equal to 1, x will be equal to tan x 1 means tan is positive in the first quadrant and the fourth quadrant. So tan x equal to 1 means it can be 45, which is pi by 4, or 225, which is 5 pi by 4, and any multiple of this. So that means it would be n pi plus pi by 4. This would be the set of values of x, right? Now, if it is given that x lies between, let's say, uh, 2 pi and um, greater than equal to 0, then there will be uh, two values of x, which are pi by 4 and 5 pi by 4. Okay. So this is the second case, which gives us this solution. And this would be the particular solution if the range is given. And case 3 is tan x equal to -1. That means tan is negative in the second and the fourth quadrant. So tan x is -1 means this would be 135 or 3 pi by 4 and 7 pi by 4. Right? So that means x would be n pi minus pi by 4. Right? So, this would be the set of solutions for this one. But in this case, the power has to be even. That means sin x has to be even. And the only even value of sin x possible is 0, which means tan x is -1, sin x is 0 is not possible. So the only set of values in this case is this. Clear? Okay. Then we can have a variant of log. So let's say log x to the power uh, x square minus 3x plus 2 equal to 1. So which means the first solution will be x equal to uh, this is equal to 0. So x equal to 1 or 2. But if x is 1, then the base becomes 0. That means we cannot accept this solution. So that means x equal to 2 is one solution. Second is the base is equal to plus 1. So log x equal to 1. That means x is equal to 10. The third solution is log x equals -1, which means this would be x would be 1 by 10, right? But for 1 by 10, I have to check whether the numerator is an even integer. So for 1 by 10, x square will be 1 by 100. So 2 plus 1 by 100 minus 3 by 10 will not be an integer. It would be 200 plus 1, 201 minus 30 by 100, which will not be an integer. So this also will not be a solution. So the only solutions here are 2 and 10. Okay. So these are four very, very important uh, variants of function based on which questions are given. Okay. Okay. Next. Now, this is, of course, the basic concept of a quadratic. So, in any quadratic, if the coefficient of x square is negative, then the parabola will face downwards, and if it's positive, the parabola will face upwards. Now, which means there are 6 set of possible cases, which are if A is positive, then we can have these 3 cases. That means there is no solution, or no roots. This is 1 root and this is 2 root. And the discriminant will be less than 0 in the first case, equal to 0 in the second case, greater than 0 in the third case. And the relationship between the discriminant and the minimum value of the function is given by this. So when discriminant is less than 0, it will be positive. So in the first case, d is less than 0, therefore y is greater than 0. And in this case, d is greater than 0, so y is less than 0, or y minimum is less than 0. So if y minimum is negative, it will be 2 roots. If y minimum is positive, then it will be no roots. So there can be a direct question like this. If x square plus kx plus 5 is greater than 0, find k. So that means here the value of y is always greater than 0. That means the y is lying fully above the x-axis. This is y greater than 0. So if y is greater than 0, that means the discriminant will be negative. That means k square minus 20 is less than 0, or k square is less than 20, or k will lie between 2 root 5 and minus 2 root 5. Right? Okay. Now, there can be another variant of this. Let's say this in combination with the previous concept. So x plus 1 by x whole square minus uh, minus uh, uh, minus 4 into x plus 1 by x plus 3 equal to 0. How many solutions will this equation have? So this is of the form a square minus 4a plus 3 equal to 0. That means a minus 3 into a minus 1 equal to 0, or a is equal to 3 or 1. But we know that a is x plus 1 by x here, and the minimum value of x plus 1 by x can be 2. So x plus 1 by x can never be equal to 1. So therefore, there will be only one solution, which is a equal to 3. Clear?
So please explain the x plus 1 by x
Clear?
part again.
Uh-huh. Okay. You have to understand the graph of x plus 1 by x very, very clearly because there are a lot of variants of that which are given. So x plus 1 by x, if you plot x plus 1 by x, okay, so you will see that when you take values of x like 0.5, okay, this would be 2.5. If you take this as zero point 0.1, this would be uh, 10.1, right? If you take x equal to 1, this would be 2. If you increase this to 2, this would be 2.5 again, etc. So the graph will be like this. And if you take the negative values, you will get the same set of values, but with a negative sign. So the graph of this will be like this, right? Which means the graph of x plus 1 by x will always be greater than equal to 2, right? Or x plus 1 by x will be less than equal to minus 2. So x plus 1 by x can never lie in the open interval minus 2 to 2. X plus 1 by x can never lie in this interval minus 2 to plus 2. Remember this as a concept. Okay. So that means if you get any values of any solution where you are getting x plus 1 by x as a value between minus 2 and plus 2, that value is not valid. Okay. Understood?
Yes, sir.
Okay. Once again, there can be a combination of this and let's say logarithmic. So log x uh, whole square uh, plus 5 log x plus 6 equal to 0, right? Right. So that means this is of the form a square plus 5a plus 6 equal to 0, which means a plus 2 into a plus 3 equal to 0. That means log log of x will be negative 2 or negative 3, right? So that means x would be 10 to the power minus 2, which is 0.01 or 0.001. Clear? Clear? Now, if the same problem is given with sine x, sine square x plus 5 sine x plus 6 equal to 0, that means sine x will come out as minus 2 or minus 3. But sine x has to lie between minus 1 and plus 1. So neither of these two values are possible. So in this case, there will be two solutions. But in this case, there will be no solution. Clear? Clear?
Yes, sir.
Okay. So we stop here for today. Tomorrow morning we have another class where I'll go through some more concepts on in algebra, some very important concepts in binomial and geometry. Okay. We have three more classes this week. Tomorrow is one, and then we have two more, one on Friday, one on Saturday. That would be in the evening, 5 p.m. Right? So I'll try and cover all the important concepts from which questions are asked, and I'm sure you'll get questions based on these concepts. Now, obviously the data, etc., will not be the same. Um, the the exact data will not be the same, but the concepts will be the same. Okay. Okay. So that's all for today. Take care. We meet again tomorrow. Bye.